Have you ever actually thought about the clothes you're wearing right now? I mean, really thought about them? We just see a sweater or a t-shirt. But what if I told you that woven into every single thread is this incredible work of engineering, a whole hidden world of geometry? Well, today, we're going to unravel the secrets of something we see every day but almost never truly understand: yarn.
So here's how we're going to break it all down. We'll start with the basics. Then we'll map out yarn's surprisingly big family tree. After that, we get to the really cool part, the secret of the twist, which is where yarn gets its strength. And finally, we're going to go full-on microscopic to see that hidden geometry and the really clever way all those tiny fibers pack together. Okay, first things first, we need to get on the same page about what yarn is, because trust me, it's a lot more complex and carefully designed than you might think. So at its heart, the official definition is pretty simple. Yarn is just a continuous strand of textile fiber. But don't let that fool you. This simple strand is literally the fundamental building block for pretty much all textiles. Without it, you don't get woven fabrics, no knitted sweaters, not even those heavy-duty ropes. It all starts right here. Now, you might think yarn is yarn, right? But it turns out there's a whole family of different types, and each one has its own unique structure. Let's take a look. Think of this chart as the official yarn family tree. As you can see, yarns get classified based on what's going on inside them, and we're about to explore some of the most important branches. Okay, so at the very top level, you've got these 5 main groups. Now, multifolded and cabled yarns are basically yarns made by twisting other yarns together for extra strength. Complex and fancy yarns, those are mostly for looks. But the foundation for all of them, the real starting point, is that first one on the list. So that's where we're going to focus: single yarns. So let's dive into that single yarn category. Right away, there's a huge difference. On one hand, you've got continuous filament yarns. Think of long, unbroken strands, kind of like fishing line. This is stuff like polyester or nylon, and it creates that smooth, silky feel. But on the other hand, you've got spun yarn. This is made by taking a bunch of short, little fibers, like cotton, and twisting them all together. That twisting is exactly why your cotton t-shirt feels soft and a little fuzzy, while a polyester shirt feels slick. And we can get even more specific inside that spun yarn category. Homogeneous yarns are the purists. They're made from just one type of fiber, like your classic 100% cotton shirt. But blended yarns, that's where things get interesting. They mix different fibers together to get the best of both worlds. A cotton polyester blend, for example, gives you the softness of cotton, but adds the durability and wrinkle resistance of polyester. Or think about good hiking socks. They blend wool for warmth with nylon for strength so you don't wear a hole in the heel. It's smart engineering. All right, so we know what yarn is made of. But that brings us to the biggest question, the real magic trick. How do you take a handful of weak, fluffy fibers and turn them into a thread that's actually strong? The answer is all in one secret ingredient: the twist. Seriously, think about it. If you take one little piece of cotton fluff, it has basically zero strength, right? You could pull it apart without even trying. So how in the world do those exact same fibers, once they're spun together, become strong enough to make clothes, or even a rope that can hold real weight? The answer, and this is really the core of everything, is geometry. When you twist the fibers, you force them into what's called an idealized helical structure. And all that means is a spiral. You know the stripes on a candy cane? That is the exact path that each tiny fiber takes around a central line. It's this beautiful, simple spiral that locks everything together and creates strength from weakness. Okay, time to put on our microscopic glasses. We're going to zoom way, way in and take a closer look at this helical structure. We're going to explore the invisible architecture that makes a simple piece of yarn a tiny engineering marvel. This diagram shows it perfectly. Just imagine this cylinder is a tiny piece of yarn. The outer radius is R, and you can see that spiral line winding its way up. Well, that line is the path of just one single fiber as it's twisted into the whole structure. You're literally looking at the helix in action. But here is the really clever part. Not every fiber travels the same way. The fibers right at the very core of the yarn, they move in an almost straight line. But to keep up, a fiber on the outside surface has to travel a much longer, much steeper spiral path. This difference creates tension and pressure inside the yarn, squeezing all the fibers together and locking them into place. That's where the real strength comes from. So this geometry has a very real effect. As you twist those fibers together, the total length of the yarn actually gets shorter. It's a phenomenon called twist contraction. The yarn becomes more compact, denser, and as a result, stronger. It's literally squeezing itself into a more powerful structure.
All right, for our last section, we're going to zoom in one final time. We've seen the spiral path the fibers take along the yarn's length, so now let's slice it open and look at a cross-section to see how they all fit together side by side. This is all about the art of packing. This image is perfect because it shows a cross-section of the two main ways fibers can be arranged. Over on the left, you've got open packing, which is, a lot looser, and then on the right, you have close packing, which is a much tighter, more efficient honeycomb structure. And the practical difference here is huge. It's all about how the yarn feels and performs. That open packing style creates a fluffier, airier yarn. Think of a soft, chunky wool sweater. By contrast, that super efficient hexagonal close packing wastes almost no space, and that gives you a yarn that's much denser, smoother, and usually a lot stronger. And this whole idea is measured by something called packing density. It's basically just the ratio of how much fiber there is compared to how much air is in the yarn. So a high packing density means very little air, giving you a yarn that feels firm and dense. A low packing density means a lot more air, and that's what gives you that softer, lighter, fluffier feel. It's amazing how this one geometric principle creates such a huge range of textures. So from the type of fiber, to the angle of that helical twist, to the way the fibers are packed, every single yarn is a product of some really smart design. The next time you pull on a sweater or tie your shoes, just take a second to remember you're not just holding a simple piece of thread. You're holding a tiny, intricate masterpiece of hidden geometry.